project, helping with development and also with the management. And looking forward to your session.
All right, thank you, Daniel. Yeah, it's a pleasure presenting here today. I think my first contact with Kamailio or SAMS back then was, I think, in 2004. So actually, it's been quite a while. What I would like to present today is Kamailio and basically my last child, RTPEngine. And I'm going to share my screen. And then we can go on. All right. So first session today is going to be RTPEngine and Kamailio, or how to simulate cores at scale. So it's actually been quite a tradition already for me in Kamailio world to present new features of RTPEngine. And in the past, they always had been quite focused on, on the server side, right? So typical use cases, Kamailio running as a SIP proxy, RTPEngine running as a media relay. And the features that I was presenting in the past were mainly directed to, call recording on the server side, DTMF injection, and all these fancy things like WebRTC transcoding. Today, it's going to be a little bit different because I've also, switched gears a bit. I'm now with SIPfront. And what we do at SIPfront is providing telecom test automation as a service. So it's about generating and simulating cores and simulating them from the cloud instead of like a local big machine. So what we are doing at SIPfront is we are trying to leverage a couple of quite interesting and rather new features of our RTPEngine. And I'm going to lead you through a couple of these features. So first one, to put the whole presentation into context, is going to be our load testing architecture at SIPfront. So how do we actually build a setup in order to test a system under test? And based on this architecture, I'm going to pick 4 different features of RTPEngine that you might never have heard of because they are really new. Like I think they are in master since 1 to 2 months, if even. And the first one is going to be RTP sinkhole. We're going to talk about nut piercing with RTPEngine, RTP echo, and RTP PubSub. So as I said, the context of the whole presentation is really that at SIPfront we develop a software as a service for telecom test automation. So if you have ever tried to simulate cores at scale, you know that core simulation is really resource intensive, right? So if you want to do like thousands of concurrent SIP cores, you really need the proper tools. And more importantly, if you want to simulate media, it's going to be really, really tough to get like a lot of concurrent cores over your network. Now, what we are using for the signaling is SIP-B. Yeah, it's nearly as old as Kamailio or SER, right? I think the first commit was in 2003, if I'm not wrong. So it aged actually very well. And what we did is, utilizing it as our signaling engine in SIPfront. We brought it to the 21st century, actually, and tried to put new control modules in place in order to orchestrate it. Because if you want to run these test simulations at scale, you're not going to have one SIP-B, you're going to have like 10, 20, 30, 40, and you also need to make them play together, right? So you want to simulate calling parties, court parties, and on the court party side, you first need to register before being able to accept calls. And all these kind of tricks can be done with SIP-B when you properly orchestrate them via certain control protocols. And for media, and this is the main focus of this presentation, like media, is going to be TCP replay. We are using TCP replay in order to generate media streams. And despite its name, you can very well simulate UDP as well with TCP replay. So what we do here is we have PCAP files for performance reasons. So we do not really want to take like a WAV file and do the generation of RTP out of these WAV files in real time, because it just takes unneeded resources, and resources are scarce in this context in any case. So we just pre-record them and then fire them over the network. And for that, we use like a PCAP with around a sample size of like 10 seconds. So this ends up with being a couple of hundred RTP packets. And then we just loop them over the network once we start the call in order to simulate the call. Now, if you're saying, hold on, wait a minute, if you're taking PCAP and just loop it again and again, then what about things like timestamps, sequences? So it's not like a stock TCP replay that we are using, rather than one with a particular RTP patch, and the link is going to be in the next slide. In order to make sure that certain RTP values are going to be incremented properly. And the other thing is we are not using CP and TCP replay to directly contact or to directly interact with the system under test. What we are using instead is Kamailio and RTPEngine in order to offload even more some of the resources that are going to be needed in order to generate and also to receive the media. So Kamailio is being used naturally as a protocol conversion for signaling, right? So instead of running TLS, for instance, over CP, we really run everything over UDP, and before it actually leaves like the test agent, it's going to be converted to TCP or TLS by Kamailio. So we are using Kamailio on a client side and on a network edge in order to communicate with test systems. And for media, we are using RTPEngine for for reflection of media and for termination of media, because as we're going to see throughout the presentation, there's actually no need to generate all the media again and again by yourself. You can just play some tricks. So if you're going to look at the architecture, then what we have at the center is always our system under test, right? So you as a customer, when you go to SIPFront, you're going to test your system. And what we are using there for the calling party is, as I said, CP, which is being basically fronted by Kamailio, right? And this CP that we have there, this is actually controlling TCP replay. So CP just generates your SIP traffic. It goes out via Kamailio to the system under test, goes from the system under test to the call party, which can also be simulated by SIPFront, which is again another Kamailio, which then passes it on to a UAS instance of CP. And for the media, we are just, from a CP perspective, just interacting, or just, let's say, directly interacting from CP to any media engine on the calling party side. So as I said, we use TCP replay and an RTP patch in order to be able to loop correctly a chunk of RTP packets in a PCAP continuously. And what we then do is the RTP traffic goes out to the system under test. CP knows about STP information that it receives back from the call party in the 200, sends out the RTP, and on the call party side, it ends up at RTPEngine that is being controlled by the Kamailio and the call party side, right? And there we are using a new feature called PierceNut and a feature called Echo, which we are going to look at in detail in the next slide. And due to this echo that RTPEngine can do, we just basically bounce back the RTP stream as a new stream with a new SSRC to the RTPEngine on the calling party side. And there we have a feature of RTPEngine called sinkhole that just terminates the RTP traffic and basically throws them away, right? So, and that is actually the first one we are going to look at in more detail, RTP sinkhole. What does this mean? What does it do? Basically, it means that sometimes you just don't want to talk. You just don't want to send out anything, right? Why? Because if we go back to our scenario, if you look at RTPEngine on the left side, the calling party side, it's never going to send any traffic out, right? Because this has actually been done by TCP replay. It just receives traffic. Now, what you want to do is you want to receive the traffic, of course, because you want to get statistics of the traffic, right? And on the other side, if there is nothing, like no entity bound on the port, then what's going to happen is that the other party is going to get a lot of ICMP port unreachable messages, and you really want to avoid that. So what you do instead is you just take the RTP traffic that you get in and you just throw it away and read the stats from it. And the way it works is really simple. So you have a signaling plane, which is basically Kamailio. And Kamailio tells RTPEngine to use a media echo called sinkhole when you establish a call for the outbound invite or when you get back at 200 OK. And that basically means that you are receiving RTP packets. You can still generate RTCP packages, right, for receiver reports. And RTPEngine can also then deliver MQTT stats in order to tell us as like a testing system about the performance of the RTP streams. And how that looks in Kamailio config and on the RTPEngine side is pretty straightforward. So what you have in the Kamailio config in our case is if a call leaves the system, leaves the calling party essentially, we do an RTPEngine offer. We tell it, okay, the direction is from internal to external. And we tell it to set the media echo to sinkhole and to generate RTCP. Media echo to sinkhole basically means that everything that comes back on that side is going to be just dropped. And the same applies for the reply route. So even if for whatever reason the CP or any entity behind RTPEngine on the calling party side is going to send something, which it won't, but it could be. We also make sure that we are going to sinkhole that traffic as well, so that the calling party is never going to emit any RTP traffic. All right, on the RTPEngine side of things, it's really straightforward, so you don't have to do anything for this feature, no special configuration or anything like that. Right. Second thing is not piercing. So you sometimes get into a scenario where both parties are like, hey, you start sending first. And the other one like, no, you start first, right? And particularly in the scenario of the called party where we would not like to generate any media by ourselves rather than just echo back what we got, we run into an issue if the called party is behind NAT, that the peer can't send anything to you, so you can't echo back anything, right? Because at that point in time, the NAT binding is basically closed, and everything that comes in from the outside towards the, let's say, to the perimeter, the external perimeter of the NAT is just going to be blocked by your router, by your NAT device. So what you can do with NAT piercing is actually a pretty simple trick. You just tell RTPEngine to send dummy RTP traffic, dummy RTP packets out to the other party that it learned through STP offer answer until the first packet comes in on this particular port. And that's about it. That's actually going to open your NAT binding. And by opening up the NAT binding, traffic can flow from the outside to your RTPEngine behind your NAT, and RTPEngine can then do its job and echo back the stream. So in a nutshell, it looks like this. So again, you have a signaling plane with Kamailio, which establishes the call to your called party on the right-hand side. It's behind NAT. So that means that Kamailio actually needs to register first and keeps the NAT open, of course. And on the media plane, Kamailio tells RTPEngine with the option pierce NUT to send this dummy traffic out to the other party until RTP arrives. And the way you do this, again, very straightforward. If we get an incoming call, then we do an RTPEngine offer to our RTPEngine instance, saying, okay, direction is going to be external to internal, and giving it the option pierce NUT. And that will instruct RTPEngine to send empty RTP packets to the SDP or to the address that is actually being defined in the SDP. And for the reply route, we can do the same. So just depending on which side of the test you are, calling party or called party, you can also do this for replies if you want, and do exactly the same. On the RTPEngine level, configuration-wise, nothing to configure, right? So you just have your interfaces and your listen port and like your control port, and that's about it. All right, and once you have utilized NUT piercing to open up your NUT binding and being able to receive these kind of RTP streams from the outside, you can then actually do RTP echo. So ideally, or at least at ZipFront in our scenario, we are combining these two features, obviously. So we do NUT piercing and we do RTP echo, because in this particular case, when we want to simulate two-way media, on a called party, there's just no need to generate again a new media stream, right? We can just take what we have and just echo it back to the other party with a new SSRC in order to, set up a new media stream. Right, and that actually, as I said, allows you to do the two-way media without the generation overhead. The way it works is, again, signaling plane is Kamailio, media plane is RTPEngine. When you get a call in, you have a new option called media echo that you can actually set to forward and backward. Right? And by doing that, you can tell which side of the media streams you actually want to echo. Right? So you could basically echo back both sides. You can only echo back one side. The way it works, again, as usual, nothing special. In our case, if we send an invite out, which is, for instance, for re-invites or something, or if we get on a reply at the 200 OK back, we just instruct RTPEngine with media echo backward and forward, respectively, to send back the RTP streams to basically where they came from. And on an RTPEngine configuration side, again, nothing special. RTP echo is being supported out of the box without any special configuration options. Right, and then we get to RTP PubSub. And this is a little bit of a special thing, and it's a really new thing, and it's not for a faint at heart. RTP PubSub is for when you want to generate one stream and you just duplicate it to multiple recipients, right? And there are a ton of use cases for that. One of the use cases is an SFU. And rumor has it that Janus is actually using RTP PubSub in RTPEngine in order to do the SFU media handling, right? So it has nothing to do with SIP, because as you might know, RTPEngine also supports WebSocket control protocol. So you don't necessarily need Kamailio. You just need an SDP and pass this SDP to RTPEngine via WebSocket, for instance. And RTPEngine will basically create the reports for you and will then, based on the SDP that you give it, will then forward your media or duplicate your media in that particular case. Other use cases for that are, for instance, SIP-Rec. So if you want to do call recording in SIP, which is, again, more related to SIP in that case, you have a call from A to B, and you want a ZipRec server basically to fetch the media that is going on there and store it somewhere, right? This is an excellent feature with subscribing to an RTP stream in order to get the stream out. Another one is interception, most interestingly, lawful interception. So instead of passively tapping media streams on your media engines, on your media servers, you can actually ask RTPEngine kindly to give you the stream. And that allows you then also to record them. Good. From the concept, it's a little bit more complex than the ones before, as I said. So you have typically a zip control, control connection, right? A control plane, and you do a call from A to B, right? So what you're doing is you're doing a normal RTPEngine offer and an RTPEngine answer in order to negotiate the media and let RTPEngine sit in the middle of that. Now, in some cases, like for instance with an SFU, or if you want to do WebRTC, you don't have this kind of zip control plane, right? You rather have some, some custom protocol based on JSON, and what you end up is you just exchange STP information from your browsers. And you just don't have Kamailio usually, right? Unless you use zip over WebSocket. So what RTPEngine offers you here is a new method called publish. And what you do there is you call publish with an STP information of for instance, the party that you want to intercept or that you want to duplicate stream-wise. And out you get an STP information of Kamailio, right? And you can use this to establish the call. Now, after that, once the call is established, either via offer answer or via publish, you can, from an outside application, for instance, a particular user agent with some extra capabilities, you can send a subscribe request to RTPEngine. And the subscribe request basically contains the call ID of the call that you're interested in and the from tag. So which leg of the streams you're interested in. And what you get out of that is the STP information from RTPEngine. And you take this and you can create a call with this. So the other side basically is going to like a recording server, like could even be probably a voice box or something, right? Something that can actually just receive RTP once a call is up. This is going to answer, and you just feed the subscribe answer or feed the STP in and subscribe answer command into RTPEngine again. And what you end up with is a RTP stream send only from RTPEngine to this interceptor element, which you can then just take and record. And the very interesting thing about that is, in the context of load generation, load testing, is you can do this as often as you want. So if you have a call, one call with two-way media, you can actually subscribe to a particular stream of this call 100 times, right? And RTPEngine is going to provide you with 100 streams, 100 copies of these streams. So you're not, you don't necessarily have to generate your own streams anymore. You just send the same stream again and again and again, context or content-wise, to the other party. Right. Now, this is typically not done in Kamailio, right? Because in Kamailio, what you have is you have your offer answer. But what I said before is you typically have your own user agent that is capable of doing extra things. And what you can do, for instance, is you can use the Node.js RTPEngine client, which communicates with RTPEngine via WebSocket from Dave Horton. And you can use this library to communicate with RTPEngine. The pity is that subscribe request, subscribe answer, unsubscribe, and publish, like the 4 commands that are interesting in this context, they are not yet supported because it's really brand new from RTPEngine perspective. So I would assume that we will get support in the next couple of days. I was able to manage to add this, although I'm really bad at JavaScript, so maybe I'm going to send a pull request for that. But anyways, you can actually very easily then control RTPEngine and control your streams in terms of streamed application using this RTPEngine client. You can also, implement your own. It doesn't really matter. You can probably even go and do this via Kamailio with XHTTP, maybe. Yeah, so sending a web request and using the RTPEngine module. Last I've seen is the commands are not supported there either, and that's why I'm saying it's really brand new on the server side. So this will take a little bit of time to actually settle and be really useful. But mentally, you can really, if you have scenarios where, say, you actually have a stream and you want to get copies of that, multiple copies, or just one copy, and you want to record that or pre-process that further, then RTP PubSub is probably the way you would like to look into. For that, again, there's nothing really special for RTPEngine to configure. There's just one thing. If you would like to communicate via WebSocket with RTPEngine, you need to give it the listen HTTP option. So this enables you to communicate both via HTTP and also via WebSocket. There's another option, of course, listen HTTPS. If you use that, and you also need to provide certificates, of course. But that would be the way to go in order to enable this feature and try it out. Right, so that was basically my insights into everything new in RTPEngine, particularly from a load generation perspective and particularly on a media generation perspective, and how we at ZipFront are addressing this particular subject. Yeah, any questions?
Thank you, Andreas. Yes, there are a couple of questions. Maybe Ole wants to relay them or even ask his questions, because it's pretty interesting based on his chatting.
Yeah, it's a really exciting presentation.
We cannot hear you well, Ole.
Oh, that's bad.
That's
bad.
Yeah.
Okay. Thank you for an exciting presentation. I'm really happy about these additions to RTPEngine. And I also kind of have a feeling that RTPEngine is stepping out to a life of its own with a lot of sexy new stuff. We got a question in YouTube from Stefan saying, have you tried using other testing tools besides ZipP for load testing? If yes, what would be those, and why not using those?
I've looked into a couple of them, and it really depends on the angle how you look at zip testing, right? For instance, for functional testing, like doing one single call and just trying to figure out how the call flow looks like, we are actually using PairZip. Yeah. So that gives us the possibility also to drive like a CLI client and actually simulate like the full behavior without looking too much into the the signaling details, because with ZipP you have to define every bits and bytes of what you're going to send. With PairZip, you're rather just saying, call this client, call this number, and once the call is established, then do a transfer, and then we can check back if that succeeded, if we still have media and so on. Right. The other angle is performance testing, and there basically, ZipP gives us all the flexibility and most importantly the performance. I think in my life in my last 15 years, I have tried to re-implement a proper performance testing tool 3 times, I guess. Yeah. And once based on BGC, once based on, I don't know, like all the SIP stacks being out there. And I just never succeeded in a way that I reached a performance in any way comparable to SIP-B, right? So instead of trying to basically reinvent this, what I did instead is taking SIP-B and extend it in a way how I need it, like being able to not get the statistics out via CSV files, for instance, rather than in real time by MQTT. And on the same way, instead of sending some UDP driving commands, being able to control my CP instances with MQTT. Right? And I think that's a much better and much more feasible option of approaching high performance SIP signaling testing rather than doing something else. I mean, it actually, I would have loved to use something readily available. And I was, some years ago, I tried to get hold of an abacus from eBay. I think they discontinued it, and I have no idea why, because it was the standard tool like 10 years ago. Yeah, and
well, we had the hammer test tool that everyone used as well.
Yeah, that's
and no one really understood fully.
Yeah. So yeah, and the other angle is actually security testing, and for that we use SipVicious Pro in a cooperation with Enable Security. So we just try to use the tools, the right tools for the right task. Yeah, and the framework that we built at SIPFront is flexible enough that we can basically put any tool or the tools that we need into this orchestration framework and just drive it. So it really doesn't matter. It doesn't have to be one tool to fit them all, right? So we can use very dedicated tools for the dedicated tasks.
Cool. Tori had a question as well. What is the advantage of using TCP relay versus the PCAP play that's built into SIP-B?
Yeah, I was looking into that. And to be honest, I had very bad experience in the past with anything related to media with SIP-B. Yeah. And I've actually checked the code. I've tried it a bit. But in the end, for me, it was just easier, and I was just feeling more confident using TCP replay with certain patches, or actually, 2 bigger patches that I had, instead of using PCAP replay in SIP-B. It was just more like a gut feeling. What I did instead is implementing a curl command in SIP-B, so that during your core processing, during going through your scenarios, I'm able to send off very quick non-blocking HTTP requests in order to drive an API and react on certain core states. So for instance, as soon as I get back at 200 OK with an SDP, I can just send out a non-blocking curl with the SDP to an API, and this API then just fires off TCP replay in order to do the media.
Is that a public patch that you?
I think it's public. I have to double check. I have to double check if I published it on GitHub. I believe I did.
So, sounds very interesting. We have another question. I think we have 2 more. One is mine. David in YouTube says, so the client can dynamically subscribe to a stream, i.e. the client asks RTPEngine to subscribe. No Kamailio involvement.
In that particular case of subscribing, you don't need Kamailio, right? I mean, if you want to do
with an extra application you had
with an extra application, for instance, yeah. So typically, you would do. I think, as far as I know, I'm not involved too deeply here. As far as I know, the actual use case why this has been implemented in the first place was really to do SIP-rec, right? So you have an application server, and you really want you have like a core, 2-way media, and you want to basically fork the RTP off to an external application, Yeah, but you can very well, like we do at Zipfron, misuse this a little bit and really leverage that to multiply a stream like 100 times or 1,000 times in order, to really just generate one stream, and then use RTPEngine to send as many streams as we need.
Yeah, that was part of my question as well. If you could duplicate it for music on hold, for instance, and stuff like that. Because multicast isn't, people aren't very happy with multicasting.
Yeah. I mean, the thing is that you basically get a send-only stream. So for music on hold, it might work. I'm just not seeing, like, out of my head the advantage here, because what you actually do is you take an existing stream and you divert it somewhere else, once or twice or multiple times.
Yeah, I could have a background stream running with beautiful Swedish ABBA music.
Yeah, but you probably still want to somehow get this stream to the particular client. I mean, here you're actually trying to pull the stream off from the client, or not really pulling it off, but copying it off and sending it to somebody else.
Yeah,
like
you have
interceptor or something.
You have to mess with a lot of re-invites and STPs and stuff. So
yeah.
But what about if you have a stream with DTLS as RTP? Do you want to duplicate that? Can RTPEngine handle multiple DTLS contexts or?
This actually works, yeah, because you are negotiating between your offer you're sending and the answer. You are negotiating a new, basically a monologue, how it's called in RTPEngine, right? And this can have completely different, could have completely different DTLS contexts here as well. So you can basically decrypt and offload the media that is flowing if you have RTPEngine in the middle doing back-to-back DLS.
Really cool. I think that was the end of my questions and the questions from the various chat channels. Thank you very, very much, Andreas. I really look forward to looking into these new features soon.
Very much appreciated.
Thank you,
Thanks for having me.